we're going to make a perfect square and estimated square roots foldable. You're going to use the piece of paper I gave you in class today. And we're going to make a perfect squares and square roots foldable. You're going to use the sheet of paper I gave you in class today. I need you to fold that sheet of paper in half burrito style, or fold it over so it makes double doors, and flatten it out. And then you're going to fold it in half again right where the double doors meet, this way, so there's a crease down the middle. Alright, now you can open that back up, and I want you to fold it in half this way. Fold it in half again, and fold it in half one more time. Push the creases down, and then you're going to open it all back up, and you should have 8 boxes down your foldable. Now we're going to fill in those 8 boxes. On the left side, we're going to have perfect squares. Perfect squares are exactly what they sound like. They are perfect squares. All right, 1 squared would make a perfect square. 2 squared would make a perfect square, and I'll show you what I mean by that. 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and 8 squared. Now we're going to open up that flap, and on the inside we're actually going to draw squares. Well, I told you that 1 squared would make a perfect square. What do I mean by that? A 1 by 1 square, which equals 1. Then we have a 2 by 2 square, which equals 1, 2, 3, 4. And then we have a 3 by 3 square, which equals 9. And this number, of course, is the area of the inside of the square. The 3's represent the height and the base of the square. The 2's, the height, the base. Okay, so then we're going to continue to fill it in on the inside until it is completely filled in. So we have a 1 by 1 square, a 2 by 2 square, which equals 4, a 3 by 3 square, which equals 9, a 4 by 4 square, which equals 16, a 5 by 5 square, which equals 25, a 6 by 6 square, which equals 36, 7 by 7 square, which equals 49, and an 8 by 8 square, which equals 64. The height of the square is 8, and the width is 8. So side and the sides are the same. And these are all perfect squares. Now I didn't draw them perfectly, but they make perfect squares if if I was a perfect artist and could proportionally draw all those little tiny blocks. All right, next we're going to take a look at the next column. In that column, we're going to put the square root with a radical symbol. The radical symbol on the inside of it, I'm going to put the number 1. 1 is the area of this square right here, and I want to know what the square root of 1 is. What times itself gives us 1? Well, 1 times 1 is 1. Okay, so what's the square root of 4? 4, again, is the area of this square. And what number squared, or to the second power, gives us 4? Well, 2 squared. or 2 to the second power, will give us 4. Okay? Sorry, I should not have written that square sign, because 2 is the square root of 4. 1 is the square root of 1. Okay, next we have the square root of 9. And I'm using these numbers here because these are perfect squares. I can easily tell you the square root of 9 is 3 squared. So 3 times 3 would give me 9. Okay, I'm going to continue to do that for the rest of my squares until my foldable looks like this. So the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, because 5 squared gives me 25, the square root of 36 is 6, the square root of 49 is 7, because 7 squared gives me 49, and the square root of 64 is 8, because 8 squared gives me 64. Okay, so all of these are perfect squares. One squared, 2 squared, 3 squared, 4 squared, and if you open it up, these squares right here match. All right, I'm now going to take my scissors and I'm going to cut along these little flaps. Perfect square, 1 squared is a 1 by 1 square, and the square root of 1 equals 1. All right, and all down this side I have perfect squares. Now what about the right side? We've completed the left side, now we've got to work on the right side. So let's move over here. I'm taking my foldable here, and I'm just going to write on the right side a question mark, because I am questioning something. If 1 squared is 1, and the square root of 1 is 1, and then we have the square root of 4 is 2, then what's the square root of 3? What's the square root of 3? All right, I'm going to fold this side back. You can keep it open if you want to. Actually, you need to keep it open. I'm going to fold this back because I'm going to use my other foldable to help me with this. Okay. All right. This is what mine looks like right now. This is my right side, this is my left side. Okay, so what is the square root of 3? I'm going to open up my left side right to where this line is, and I drew a line. I have 2 boxes here, and I wrote square root of 3, and I drew a line at the end of those 2 boxes. You can go ahead and separate the next 2 boxes with a line, that way it's already done. You should have 1, 2, 3, 4 sections here. Anyways, the square root of 3. Well, I don't see that over here. So what could the square root of 3 be? I need to ask myself 2 things. First of all, the square root of 3, and I'm going to go ahead and completely open up the left side. What's the square root of 3 closest to? The square root of 1, 4, 9, 16. And I'm looking, it's definitely not closer to these down here. It's closest to these 2, square root of 1 and square root of 4. The square root of 3, is it closer to the square root of 1 or is it closer to the square root of 4? The square root of 3 is 2 away from the square root of 1, and it's 1 away from the square root of 4. So it's definitely closer to the square root of 4. So the square root of 3, I could say, and I'm going to open up this flap, is about 2. So my answer is an estimated answer. The square root of 3 is about 2. Now, how did I find that? I found that the square root of 3 was about 2 because the square root of 3 is closer to the square root of 4 than it is to any of the other perfect squares over here. And so, since I know that the square root of 4 is 2, I know that the square root of 3 has to be close to 2. So I'm estimating that it's about 2. So the answer, again, is an estimate. The square root of 3 equals about 2. We found that because the square root of 3 is between the square root of 1 and the square root of 4. And the square root of 3, the second thing that we had to ask ourselves is, what is the square root of 3 closer to? The square root of 3 is closer to 4. All right, let's try the next one. All right, this time we're going to estimate the square root of 14. The square root of 14. Is the square root of 14 closer to the square root of 9 or the square root of 16? Well, 14 is 5 away from 9, and it's 2 away from 16. So it's going to be closer to the square root of 16. So the square root of 14 is about 4. Again, it's an estimate. So the answer, again an estimate, 1. The first thing that we did is the square root of 14 is between the square root of 9 and the square root of 16. 2, the square root of 14 is closer to the square root of 16. So the square root of 14 must be about 4 since the square root of 16 is 4. All right, let's try the next one. Next, we have the square root of 28. The square root of 28. 28 comes between 25 and 36. And 28 is closer to 25 than it is to 36 because 28 is only 3 away from 25 and 28 is 8 away from 36. So, I can estimate that the square root of 28 is about 5. Again, we estimated the answer. The square root of 28 is about 5. The square root of 28 is between the square root of 25 and the square root of 36. The square root of 28 is closer to the square root of 25. And that's how I came out with my estimate. All right, last one. What is the estimated square root of 52? Well, 52 is 3, What is the estimated square root of 52? 52 is 3 away from 49, and 52 is 12 away from 64. So it is definitely closer to 49. So I can estimate that the square root of 52 is about 7. So the answer, again, is an estimate. The square root of 52 is about 7. How did we figure that out? Well, first of all, 52, the square root of 52 is between the square root of 49 and the square root of 64. And 2, the square root of 52 is closer to the square root of 49. So that's how you figure out estimated square roots. So close up your foldable. The left side of our foldable is perfect squares. The right side, these are estimated, the left side of our foldable is perfect squares and the right side is estimated square roots. So estimated square roots.